Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. We post videos covering topics found throughout college mathematics, beginning from algebra up through calculus and more advanced topics as well. If that's something that you're looking for, please consider subscribing and checking out some of our other videos. Let's go ahead and get into the current one. What I want to do is I want to take a look at perpendicular lines and their corresponding slopes. What's the relationship between slopes of perpendicular lines? Well, let's talk about what are perpendicular lines first. So first and foremost, two lines in the xy plane are perpendicular if they cross at a 90-degree angle. Now there's two cases that I want to consider. Okay, so two cases that I want to take a look at. Well, the only two cases. Let's see. Okay. So one situation is you could have a horizontal line and a vertical line. Okay. So you've got a horizontal line and a vertical line, and of course they do cross at a 90-degree angle. Now remember that a horizontal line the slope is 0. And for a vertical line, the slope is undefined. So if I have a pair of lines that are perpendicular and one is horizontal and one's vertical, then I know that the slopes are, the relationship between the slopes is one is 0 and one is undefined. Okay, what about the other case? What about when I have a line that looks like this, and then I've got a line perpendicular to that, and once again they cross at a 90-degree angle. What I want to investigate is what is the relationship between the slopes of those two lines in this second case. So what I'm going to do is I'm going to draw this, but I'm going to do it a little bit bigger. So let me see if I can do that over here, see if I've got enough space. Okay, so let's say one of my lines is here, and I'm going to do a line that's perpendicular to that, so it would look, let's go up here, like this. Okay, and of course pass through at a 90-degree angle. Let's take a look at the relationship between the slopes. Remember, the slope is the rise over the run. So if I just do that pictorially here with a rise and then a run, and then I'm going to label those. I'm going to say that the rise, I'm going to label it as the quantity A, and the run, I'll label that as the quantity B. Well, I'm going to do the same sort of diagram on the pink line. So on the pink line, we can see that if I do say a rise, and then a run. Okay. So notice that the triangle is going to have a very similar shape to it. And let's label the quantity. So let's say the rise here I labeled as A. So over here, let's say that the rise is C. And let's say that the run I'll label as D, just like I labeled the run over here. All right, well, what are the relationships between those quantities? Since the triangles look very similar, we can see that the value of A is the same thing as the value of D. So the value of A is equal to the value of D. That is, the rise of this line is the same thing as the run of this line. Now what about the value of B? Okay, so the value of B, well, that's the run of this one, and it looks like it's the same length as the rise of this one. However, notice that this one is negative because the slope is negative in this one. So B is equal to negative C. So we can see that those relationships based on the triangles that I put on those perpendicular lines. Well, the slope of this this line right here is, again, it's rise over run, so it's A over B. So I see that A over B is equal to, well, we just have some relationships right here with A and B. A is the same thing as D, and B is the same thing as negative C. Well, for one thing, I could take that negative and I could pull it out front, so negative D over C. But let's go back to this pink line here. The slope of this is it's rise over run, so it's C over D. And what I'd like to do is I'd like to rewrite this expression so that I can get the slope of this pink line out of it. And notice that what I can do with D over C is that's the same thing as writing 1 over C over D. So here's the conclusion. The slope of this line, which is A over B, is the negative reciprocal of the slope of this line. So if I've got lines that are perpendicular and they're not horizontal and vertical, the lines have negative reciprocal slopes. Okay. Thank you for watching, and please consider subscribing, checking out some of our other videos.